In this video, we're going to be talking about different types of clouds. So first, let's start off with the common clouds. The first common cloud we're going to be talking about are cumulus clouds. Cumulus clouds are these big puffy clouds that are located in the lower part of the troposphere. Keep in mind that this entire area is located in the troposphere. Next, after cumulus, is stratus clouds. Stratus clouds are kind of thin, but they are layered out, and instead of being puffy like the cumulus clouds, they layer out the entire lower part of the troposphere. So they're also known for being able to cover the entire sky, so the sun can't exactly go through it. So there are also many other kinds of clouds that have traits of both of these main clouds. One is stratocumulus, which has both features of stratus and cumulus clouds. It's long and also blocks out the sun, but they're more puffier than the actual stratus clouds. Then we have nimbostratus clouds. Nimbostratus clouds are known for having a lot of rain, so they're the ones who hold rain, but they also cover the entire sky. So another one is altocumulus. Alto means middle, and it also has features of cumulus clouds. However, instead of being puffed up into this cloud over here, it's just a bunch of other smaller puffy clouds that are near each other. Then there's altostratus, so it's also middle, but here it contains features of stratus rather than cumulus, hence the name stratus in the word. So stratus, it's in the middle layer of the troposphere, and like being at the lower layer of the troposphere, it's at the middle layer, and in the middle layer, it also covers the sky, so the sun also can't penetrate through it. And lastly, it's also the higher part of the clouds. So we have cirrostratus. Cirro means high, and we have these cirrus clouds, which are just thin strips of clouds located at the higher part of the troposphere. Then, of course, we have cirrostratus and cirrocumulus. Cirrocumulus has features of cumulus clouds located in the higher part, and cirrostratus has features of the stratus clouds located in the higher parts. So cirro means high. This cirrostratus, it's unlike it being a little bit thick like the stratus or altostratus, it's much more thinner because there isn't exactly a lot of water vapor that goes up to these higher parts of the troposphere, hence the reason it's so thin. So cirrostratus has the exact same features as stratus. It covers the ground, however, the sun is able to penetrate it more easily. Then cirrocumulus, it's less puffier than the cumulus or altocumulus, but also has the same features of altocumulus because they're not puffed together in one big cloud, but rather way more smaller puffy clouds all together. And then lastly, we have the cumulonimbus. So cumulonimbus is kind of similar to nimbostratus. However, cumulonimbus, instead of going horizontally, they extend vertically. Because they extend vertically, they might start out in the low troposphere, but could reach up to the high troposphere. Cumulonimbus and nimbostratus both signify rain, and cumulonimbus is especially notoriously known for its thunderstorms and a lot of the storms that it comes along with it. Alright, after going through a brief overview of the common clouds, we're going through unusual or rare clouds that you could sometimes see as you're walking by. So let's start off with the first one, which is nacreous clouds. Nacreous clouds is the most rarest clouds of all the different types of clouds in this region, in this paper over here. So nacreous clouds, also basically mother of pearl clouds, are basically formed in the Arctic or near the Arctic areas. So they can be found in the Arctic area or the Antarctic area. But wherever that is, done in a windy temperature and a cold temperature. Now, nacreous clouds are really rare because number one, it's winter, and in a lot of the Arctic and Antarctic areas, the sun can't exactly evaporate water as fast because there isn't enough heat in those areas to be able to evaporate that water, hence making it very difficult. They appear in vivid colors because the sunlight, it interacts with those water droplets, and whenever light passes through a medium, that white light is reflected off into multiple different colors, hence we get these kind of vivid colors such as pink, purple, blue, green, or red. Next is noctilucent clouds, also known as polar mesospheric clouds. Noctilucent clouds form in the mesosphere. The mesosphere is a part of the atmosphere where it is very cold. In this area, you could expect a lot of instead of whenever the water evaporates, unlike it being in the troposphere where it remains as a water droplet, because it's going up to the mesosphere level, and since in the mesosphere it's very cold, that area will then turn the water droplets into ice crystals, which form around these tiny dust particles, which create the condensed clouds over there. Now, when these ice crystals form around the tiny dust particles, the light also passes through, so it's kind of similar to nacreous clouds. However, the light passes through and it doesn't display off those vivid colors. Rather, it gives off these blue or silvery colors, and it's only visible at sunset. However, nacreous clouds is only visible during the winter time or polar winter time in those areas. Noctilucid clouds are also the highest and coldest clouds. Next is the Kelvin-Helmholtz clouds. We have the clouds that are formed mainly in the stratosphere or the troposphere. Okay, so we know the part where hot air rises and cold air falls down. So what happens is the hot air moves at a different speed, but the cold air moves at a different speed. Because these two are moving at different speeds, what happens is that there's a lot of disturbance into the cloud. And when the hot air, it's continuing to rise up. So it brings a little speck of that cloud up. And because that hot air in general is moving at a different speed compared to the cold air, it's creating that curve. So instead of just going straight up, it creates that curve along with it. Hence, it looks like water waves. All right, then we have mushroom clouds. Mushroom clouds are not exactly formed naturally. They're caused by disturbance. So this could include a nuclear explosion or a kind of volcanic eruption that happened. Some examples where this has been displayed in the past would be like Pompeii or the nuclear droppings of Hiroshima and Nagasaki. Mushroom clouds have been found over there. They have not been found due to nature unless it involves volcanoes. Then is shelf clouds. So we talked about how cold air sinks and how hot air rises. Now what happens is typically in areas where the climate is warm or humid, what happens is sometimes a cold front can hit the area. Now this cold front brings in cold air and cold temperature. And then a lot of the air is moving up and the hot air is moving up and the cold air is sinking down. This creates the shelf appearance or the blanket appearance as if the air is actually covering over the entire thing. However, in most situations, it hasn't fully covered the entire thing. Hence, it seems as if there's a shelf or a wall between the area where it's not covered and the area where it is covered. Hence, shelf clouds. Also, shelf clouds are a different type of Arcus clouds. So an Arcus cloud, if you're wondering, is basically where cold air moves into a hot or humid area. That's an Arcus cloud. All right, then are rolled clouds. Roll clouds is another type of Arcus clouds. It's kind of similar to shelf clouds, and it also happens when cold air enters into a warm air or humid environment. But whatever happens is the warm air rises and the cold air falls, and what happens is the water vapor, unlike it moving all together in a shelf cloud, what happens is the water vapor sticks to the dust that's happening from the difference in the air pressures. It sticks to the dust, and these droplets, when they stick around the dust, they start to create these clouds, and because they're not moving all together, they create this humongous bunch over here. This bunch makes it look as if it's rolling and rolling and rolling, hence the name roll cloud. So shelf clouds and roll clouds, which are Arcus clouds. So shelf clouds, they do bring thunderstorms like tornadoes, and they also can bring storms such as lightning or other kinds of things that could cause damage to the environment. Meanwhile, roll clouds, they don't cause tornadoes, but they do also cause thunderstorms. Next is lenticular clouds. Kind of like the same theory. Cold air comes to the bottom, hot air comes up. This water vapor, it happens over a mountain. Mainly if there's a caldera, which is this like large part around a volcano, and in this caldera, if there's water inside and if the temperatures are just right, it evaporates, and when it evaporates, the water vapor cools over here in the stratosphere, and then we have this cloud. The hot air rises, the cold air sinks. Now, on the top of the mountain, there's a lot of wind movement. And because there's a lot of wind movement, it causes these small crevices or cracks around that cloud, which then give it this kind of floating disc kind of cloud shape. Hence, we have a lenticular cloud forming over here. Then there's mammatus clouds. So mammatus clouds also involves hot air rising and cold air sinking. However, when the cold air sinks, the hot air is rising at the exact same time, which then creates a small pouch. These small pouches fall down, which then create this mammatus clouds over here. This doesn't last very long, however, because eventually the atmosphere will, not be disturbed, and the atmospheric pressures will be right, and this won't last long at all, okay? It looks like a cellular pattern or pouches or bulges that are basically hanging down from the cloud. So they're kind of a sign for an oncoming or passing storm. Next is the undulatus or asperatus clouds. They create this kind of watering or rippling effect. So what happens is there's two different kinds of wind speeds. So there's the actual cloud that's falling over here, but then there's probably some kind of like other front that's affecting this, and now there's two different kinds of wind speeds. This wind speed goes directly into the cloud, which then gives it that kind of rippling effect that makes it look like it's like as if you're underwater. So that's kind of how. It's also rare, and these clouds, they typically aren't like the ones that cause storms or any kind of rain that happens. So they're not considered nimbostratus, but rather stratus or altostratus, or maybe even stratocumulus. All right, then we have contrail clouds. So contrail clouds are like these jet-like line. They're basically line-shaped clouds that form behind airplanes. So have you ever seen like a jet in the air that just flies through, and then there's like a humongous trail of like gas and like this kind of cloud or air that like is left behind? Yeah, these are contrail clouds. So basically, airplanes, they leave behind a lot of hot and humid exhaust, and this mixes with the cold, low vapor air that's located inside of the atmosphere. Hence, we get these kind of clouds, contrail clouds. So, contrail clouds trap radiations in Earth's atmosphere, and because of this, they help in the global warming problem. These are not symbols of any like storm or anything. So like, if you see this, there's really nothing happening in the atmosphere. This is more man-made. It's caused by man-made objects. All right, and lastly, we have orographic clouds. Orographic clouds look kind of similar to lenticular clouds. However, they don't sit or form on a mountain. Instead, orographic clouds move along throughout time. So what's happening is it starts off as a regular cloud. Hot air rises, cold air sinks. And what happens is the orographic clouds, it moves through along with the mountain, and eventually all the clouds, they bunch up together, and it kind of looks like a lenticular cloud. However, it's not disc shape where you see kind of these crevices. They're all patched together, and they slowly move through the mountain. However, as they exit like the path of the mountain, they return back to their regular shape as like a cumulus cloud, cumulonimbus cloud, or a nimbostratus cloud. So these clouds, they typically hold precipitation such as rain, or they could probably snow if they have too much, and they might snow on the mountain. But other than that, they really are basically cumulonimbus and nimbostratus clouds that are like moving through a mountain, and they're giving rain to another area across the mountain. So these are all about the different types of common clouds, and we also viewed the unusual or rare clouds.